Okay. Tell me the statement of the problem. Given polynomial p of x is equal to,
so x raised to 5
just a moment, this thing is not connected board. X raised to 5 p of x
plus 2 x raised to 5 plus 2x raised to 4 minus 3x cubed plus x square minus 3x plus 5.
and what are we
Then
saying?
p equals 2 minus root 3. And you have to find pk. 2 minus root 3.
Okay. So the approach that we are taking is, if k minus root 3 is the value of k, then if we consider one more value of k as 2 plus root 3, then we can create quadratic equation whose solution is these two values. There are two ways of doing it. One way is to process this, root 3 is equal to 2 minus k. Therefore, 3 is equal to 4 minus 4k plus k square, which is equal to k square minus 4k minus 1 is equal to 0. So this is a quadratic in k, and 2 minus root 3 will definitely satisfy this quadratic. Which another number will satisfy? 2 plus root 3. Minus च्या ऐवजी इथे प्लस पाहिजे ना. Okay. So we say that k is a root of x square minus 4x plus 1 is equal to 0. It is same. K is a root. Okay. So if we can write f of p of x as x square minus 4x plus 1 and into ax cube plus bx square plus cx plus d, which is a cubic polynomial. This is square polynomial, degree 2. We want to make degree 5, so we have made it. But it is not necessary that eventually you will get everything falling in place, because this might not be factor of this. Therefore, you may end up getting remainder, which is ux plus v. Degree 1 remainder you may end up getting, right? So basically, if we substitute p of k in this equation now, of course this is going to be equal to 0, and therefore we need not have to worry about this quantity. How much will be the value of this term? We need not have to worry, because anyway it is going to get multiplied by 0, and hence it is going to be 0. Therefore, p of x is going to be, p of k is eventually going to be 0 plus uk plus v. That is what is going to be the value of p of k. Namaste ka. And therefore what I had suggested in the end of last lecture was x raised to 5 plus 2x fourth minus 3x cubed plus x square minus 3x plus 5. When you are dividing by quadratic equation, it is better to go for long division rather than method of forcing factor. Method of forcing factor is easy when this is binomial, 2 terms, not 3 terms. Okay, so let us perform the long division very quickly, so that we are interested in this. We are interested in ux, knowing what is ux plus v, and ux plus v will give us the remainder. So I have to multiply by x raised to 5, makes it minus 4x4 plus x cube. Changing signs of all of them, 0 plus 6x4 minus 4x cube plus x square minus 3x plus 5. Now I have to write plus 6 x square. So 6x fourth minus 24x cube plus 6x square, and therefore it is equal to 0x4 4 plus 20x cube minus 5x square minus 3x plus 5. I have to put 20 here now. 20x makes it 20x cube minus 80x square plus 20x makes it 0 plus 75x square minus 23x plus 5, and I have to write plus 75 here. That makes it 75x square minus 300x plus 75. That means our ux plus v is 300 minus 23 is 277 x minus 70. Okay, so 277 into 2 minus root 3 minus 70 is our p of k. We can do this now. Subodh's विचाराचे समजून minus 70 minus 277 root 3, which is equal to 484 minus 277 root 3. This is what is the P of K. Okay. Let me give you another problem now. Factorize.
Sir, for just 1 minute, could you put out?
Yes, I will do it. Just let me write down this problem. Factorize x raised to 10 plus x raised to 5 plus 1 into 2 factors. Right? So I give you sufficient time to deal with this problem. Okay. X raised to 10 plus x raised to 5 plus 1 happens to be factor of x raised to 15 minus 1. The first factor will be x raised to 5 minus 1. How do you get the idea of this factorization? Because if you replace x raised to 5 by t, you get t square plus t plus 1, which happens to be the second factor of t cube minus 1. Right? Therefore, we are looking at x raised to 15 minus 1 instead of looking at this. Okay. So x raised to 15 minus 1 can be further factorized in one more way, which is x cube minus 1 into, there will be some second factor here, whose degree will be 12. Yes or no? Yes. So now if we just ignore this from our calculation and equate these two guys, then what will happen? X minus 1 into x4 plus x cube plus x square plus x plus 1, that is the further factorization of x raised to 5 minus 1 into x raised to 10 plus x raised to 5 plus 1 should be equal to x minus 1 into x cube, sorry, x square plus x plus 1 into some factor x raised to 12. Yes or no? Maybe I can write this x raised to 12 plus x raised to 9 plus x raised to 6 plus x raised to 3 plus 1. X raised to 12 plus x raised to 9 plus x raised to 6 plus x raised to 3 plus 1. Are you there up to this point? Now when we see these two LHS and RHS, we can always cancel this out because it is same. And then if I take only x raised to 10 plus x raised to 5 plus 1 on LHS, then I have x square plus x plus 1 into x raised to 12 plus x raised to 9 plus x raised to 6 plus x cube plus 1 divided by x fourth plus x cube plus x square plus x plus 1. And
Sir,
we
x
ask,
to the 10th. You
uh,
have said it is x to the 12th. Sir, on right hand side.
ah, ah. So basically we are asked to factorize this, and this is what is RHS looking like. So if this problem is correct, then this ratio will look like a product eventually. Now fourth degree polynomial cannot be absorbed in degree 2 polynomial. Therefore, if at all these are the factors, then this must be divisible. X raised to 12 plus x raised to 9 plus x raised to 6 plus x cube plus 1 should be divisible by this. Then we have a factorization with us. अरे समझते का?
Yes.
And
Yes.
hence we perform long division. X raised to 12 plus x raised to 9 plus x raised to 6 plus x raised to 3 plus 1 divided by x raised to 4 plus x cube plus x square plus x plus 1. We perform long division. First factor is x raised to 8. After writing x raised to 8, what are we going to get? X raised to 12 plus x raised to 11 plus x raised to 10 plus x raised to 9 plus x raised to 8 plus x raised to 9 from here. Sorry. After subtracting, we are supposed to do this. Okay, you subtract it from here. 0 minus x square 11 minus x raised to 10, right? Oh, then x, this is getting cancelled. Minus x raised to 8 plus x raised to 6 plus x cube plus 1. I am very poor in long division, so you have to watch me doing that. Now x raised to 7 minus x raised to 7 minus 11 minus x raised to 10 minus x raised to 9 minus x raised to 8 minus x raised to 7. If we subtract 0, oh, we get 0 one more time. Then minus x raised to 9, then 0, then minus x raised to 7 plus x raised to 6 plus x cube plus 1. Now the largest term is minus 1 x cube x raised to 9. So is that right?
X restaurant positive, ते positive पाहिजे ना.
This should be plus and this should be plus. सगळे प्लस पाहिजे. खालचे सगळे प्लस होणार ना. म्हणजे सगळे प्लस. So the next factor is x raised to 5. X raised to 5 plus x raised to 4 plus x raised to 3 plus x raised to 2.
Sir, x raised to 9 plus.
संपलं कसं इतक्या लवकर? x raised to 9 plus x raised to 8 plus x raised to 7 plus x raised to 6 plus x raised to 5. That makes it 0 minus x raised to 8. 7 7 6 6 दोन्ही गेले. हे काय चाललंय काय? बरं. Minus x raised to 5 plus x raised to 3 plus 1 plus 1. बरोबर आहे? चुकणार आहे कुठेतरी. Anyway, minus x raised to 4 minus x raised to 8 minus x raised to 7 minus x raised to 6 minus x raised to 5 minus x raised to 4. We subtract 0 plus x7 plus x6, 5 is gone, plus x4 plus x cube plus 1 plus x cube makes it x raised to 7 plus x raised to 6 plus x raised to 5 plus x raised to 4 plus x raised to 3 makes it 0, 0 minus x raised to 5, 0, 0 plus 1. Deva plus or minus 1. Really?
Sir, minus x plus 1.
minus x plus 1.
हो सर मायनस एक्स प्लस वन.
अच्छा अच्छा, अजून एक आहे ना काय डिग्री 5 टर्म पाहिजे नाही काय? हो ओके. दॅट इज व्हॉट आय वॉज थिंकिंग. कसं काय चुकलं एवढं करून? ओके, सो मायनस एक्स इज माय क्वोशंट नाव. Minus x is my quotient. That makes it minus x fifth, minus x fourth, minus x cube, minus x square second, minus x. What remains is 0, x fourth plus x cube plus x square plus x plus 1 plus 1 is equal to x fourth plus x cube plus x square plus x plus 1 makes it 0. Oh, 0 remainder. That means this is the second factor, degree 8. Correct. This is degree 2. This is degree 10. Therefore, we must get degree 8 factor, and the factor looks like this. That is what is the complete factorization of given polynomial. आता इथे एक तुम्हाला गंमत सांगून टाकतो. ॲक्च्युली दॅट इज अ फन. when we learn complex numbers, this problem is very, very easy. Okay, but maybe this is going to be very useful trick for you. Therefore, I am telling you, I will explain you again when we learn complex numbers next year. Now you tell me what is the factorization of x cube minus 1. Can you tell me what is the factorization of x cube minus 1? It is, bola,
X minus 1 into x square plus x plus 1.
correct? Now this is quadratic equation, and if we try to solve, we get x is equal to minus 1 plus minus under root b square minus 4ac upon 2, which is minus half plus minus under root 1 upon 2 root 3. Oh, minus 3. Bad luck. So when something negative goes inside radical sign, we are stuck in real numbers. Therefore, we say that this is irreducible quadratic equation. It cannot be further reduced in real numbers. If this minus 3 was not there inside radical, we would have reduced it further. But now we cannot. But then, okay, forget about this. We will learn next year. I can do it like this, minus 1. Then this is definitely going to get factorized into linear factors, and they are not going to be real numbers. So I can call one of them as omega. This is not real numbers like 1, 2, 3, 4. This is different. And so there will be another factor which we don't know what it is. We will write it. But what I am trying to tell you right now is I am assuming that omega is a factor of this. If I substitute some new number omega, which if I substitute in this polynomial, I get 0. So suppose I say p of x is equal to x square plus x plus 1. What is p of omega? 0. Suppose, and therefore I say x minus omega is a factor of this. Suppose there exists a number like this. Then what do you think? Suppose q of x is equal to x cube minus 1. Then what is q of omega? What is q of omega?
0.
0. This implies x minus omega is a factor of x cube minus 1. Okay. But then we are actually solving x cube minus 1 is equal to 0, means we are solving x cube is equal to 1. Yes or no? Yes. So if x is equal to 1, this statement is true. And if x is equal to omega, again this statement is going to be true because omega is a factor of this. That means omega cube is equal to 1. Yes or no? Like 1 cube is equal to 1, omega cube is also going to be equal to 1. Yes or no? Yes. And suppose now I say that the third factor is say beta, then when I multiply these two guys, what is going to happen? X square minus omega plus beta times x plus omega beta. Yes or no? Therefore, and this is going to be equal to x square plus x plus 1. What does it mean? It means omega plus beta is equal to minus 1 and omega beta is equal to 1. Yes or no? But omega cube is equal to 1. Also omega cube is equal to 1. Therefore, beta is equal to omega square. Moreover, omega plus omega square is equal to minus 1. This is also true. So, if I have not real number but some number which makes this polynomial 0, then will that omega make p of x is equal to x raised to 10 plus x raised to 5 plus 1. Okay, so what is p of omega? Let us see. P of omega is equal to omega raised to 10 plus omega raised to 5 plus 1, which is equal to omega raised to 3, omega raised to 3 raised to 3 into omega plus omega raised to 3 into omega square plus 1. However, our omega cube was 1. So 1 cube is 1, which is omega. 1 cube is 1, therefore this is omega square plus 1. And we know that 1 plus omega square is equal to minus 1. Therefore, this is equal to 0. That means x minus omega is factor of x raised to 10 plus x raised to 5 plus 1. Very good. So if x minus omega is a factor, then x square plus x plus 1 also will be a factor of this, and hence you can directly find out the second factor by long division. Now, this was easy. This was doable from some other method. But using this theory, I can tell you that, say, consider another polynomial p of x is equal to, say, bad numbers, x raised to 7 plus x raised to 5 plus 1. Right? What will be p of omega? Omega raised to 7, which is omega raised to 3 raised to 2 times omega plus omega raised to 3 into omega square plus 1. Yes or no? Again, I have done the same thing. Omega plus omega square plus 1, which is going to be equal to 0. This is very bad polynomial. There is no symmetry about it, but still x square plus x plus 1 is going to be the factor. X raised to 7 plus x raised to 5 plus 1 is equal to x square plus x plus 1. I am sure about it because P of omega is 0. Now let us check whether P of omega square is also 0. Omega square raised to 3, which is omega. I know. Omega square raised to 3 is omega into omega. Omega square into omega cube, which is omega square and 1. So this is going to be factor of this. It looks so bad. Try to find out the second factor. Question. X raised to x raised to 8 plus x raised to k plus 1 is divisible by x square plus x plus 1. Find all values of k such that k is single digit number, positive integer. आता तयार झाला माझ्या डोक्यात हा प्रश्न. आम्ही 10वीच्या परीक्षेत विचारणार पुढच्या वर्षी. Answer is x raised to 8 plus x raised to k plus 1 is x raised to 3 raised to 2 x square plus you want x raised to 3 raised to something times x plus 1. Then only if you substitute x is equal to omega, this is going to be 1 plus x plus, you have to have t here, 1 plus x square, that will become 0 and hence this is going to be factor. Is that correct? So either it should be, if t is equal to 0, then k is equal to 1. If t is equal to 1, then k is equal to 4. If t is equal to 2, then k is equal to 7. If t is equal to 3, then it is a double digit number, 10. So all possible values of k are 1, 4 and 7. That makes this fellow power 1. And this is x raised to 3 will become 1 the moment you substitute omega. X raised to 3 raised to 2 will become 1 the moment you substitute omega, and therefore it will be omega square plus omega plus 1, which is going to be 0, and hence this would be the factor. So all possible values of k are 1, 4 and 7. It is easy. Good. Now let us move.
Sir,
Yes.
sir, if we take t as -1, we will get the negative values of k now.
If you take k, t is minus, but then it is said, it is positive. K should be single digit positive integer. It is given here, single digit positive integer. Therefore, we have to take values of t equal to 0, starting from 0 only. Okay, now next. Now, polynomial in x, p of x, we said is equal to an x raised to n plus an minus 1 x raised to n minus 1 plus n minus 2 x raised to n minus 2 plus dot 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 plus a2x square plus a1x plus a0. That is what we said, polynomial over reals where all the coefficients are real numbers and an is not equal to 0. That is what we said. And also we said that this p of x will have at most n distinct roots. N distinct roots. So we can write this as first root is say alpha 1, second root is say alpha 2, third root say alpha 3, array x minus third factor alpha 3 dot dot dot. Suppose all the factors are distinct, then it will look like this. And then what will be the last factor? X minus alpha n. Is this true? If alpha 1 is somebody who's, if I substitute in place of x, it makes p of x equal to 0. Therefore, x minus alpha 1 is a factor. X minus alpha 2 is similarly a factor. X minus alpha 3 is similarly a factor, etc. But then, is this equal to this? Is this going to be equal to this eventually? If we really cross multiply, may not be, because when we take all x from all n brackets, we will generate x raised to n and not a n x raised to n. Therefore, we need to write a n here. Okay. बघा समजतंय का? Say for example, I say 3x cube minus 2x square plus x plus 5 gets factorized like x minus alpha 1 into x minus alpha 2 into x minus alpha 3. Suppose I write it like this, then is it going to be true for any value of alpha, beta, gamma? No. It will be true only if I write 3 here, because I am generating 3x cube, and now I can deal with alpha 1, alpha 2, alpha 3. They might be fractions, they might be irrational numbers, whatever. But then this 3 over here is compulsory when I am equating these two. Corresponding coefficients must be equal. Two polynomials are equal if their corresponding coefficients are equal. So without this, I am not equaling the coefficient of x raised to 3, which I must. Therefore, it is important that I write 3 here. Similarly, I write an here. Good observation. P of x is equal to a3. Let me change the color. Green. P of x is equal to a3x cube plus a2x square plus a1x plus a0, which is also equal to 2 times x minus 1 into x plus 1 into x minus 3. Find a3, a2, a1, a0. काढा बघू. बंद होतं. Okay. Next problem will be this numerical a2. Third problem will be yet another numerical a3. do some observations. How are you arriving at all these A0, A1, A2, A3, dot, 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 whatever required, observe, and then arrive at conjecture and write down what should be in this case, an minus 1, etc., and what should be the general term AR, which is going to be coefficient of x raised to r when you multiply all these factors together. Okay, I'm interested in looking at AR. Notation. Say if I am doing with quadratic equation like this, so x minus alpha 1 into x minus alpha 2 will give me x square minus alpha 1 plus alpha 2 times x plus alpha 1 alpha 2. If I am doing like x minus alpha 1 into x minus alpha 2 into x minus alpha 3, then I will get x cube minus alpha 1 plus alpha 2 plus alpha 3 plus alpha 1 alpha 2
Sir, x square.
x square plus alpha 1 alpha 2 plus alpha 2 alpha 3 plus alpha 3 alpha 1 x plus minus alpha 1 alpha 2 alpha 3. I will get like this. So first bracket that you get is sum of all these roots here also. Second bracket you get as multiply 2 at a time. Choose any two amongst all of them, multiply them and add them. Third, multiply all of them. Something like that we are getting. That is what is our observation. Okay, so if this is known to us, then answer for this is equal to, this is going to be equal to, sum of the roots is my first coefficient is equal to 5 into x square, sum of the roots minus the root here is 3 and minus 2, so plus 1 is sum of the root, opposite of plus 1 times x, and what is the product of the roots? 3 into minus 2, which is minus 6. That is product of the root. Oh, this is correct. So now if we want to do this, then how do we write? Is equal to 2 inside bracket x raised to 3, sum of the roots 1 minus 1 3 minus 3x square, roots are 1 minus 1 and 3, so sum of the roots is 3, so minus 3, then next sign is plus, 2 at a time, minus 1 minus 3 plus 3. So if we add 2 at a time, we get minus 1 times x minus product of all of them. 3 into minus 1 into 1 is minus 3. Minus minus. This is what is going to be the multiplication. So every time we need not have to write down all these terms. We just focus on the coefficients and focus on the roots. We will be able to write down this. Now, in case of 4, it will be little cumbersome, but we can do it. 1, 2, minus 1, minus 3. These are the roots. Therefore, is equal to 2 inside bracket x raised to 4. Sum of all of them, minus 4 plus 3 is minus 1. So, plus x cube. 2 at a time. This into this is 2. This into this is minus 1. This into this is minus 3. This into this is minus 2. This into this is minus 6. This into this is 3. Sum of these many numbers. 6, 7, 8, 9, 10, 11, 12 वजा 5 minus 7. Then 3 at a time. 1, 2, 3. Product of them is minus 2. 1, 2, minus 3. product of them is minus 6. Then 1, 3, 4, product of them is 3. And then 2, 3, 4, product of them is 6. Answer is, sum of them is plus 1. Minus plus minus x, right? And then product of all of them, minus plus minus, therefore last one is plus, product of all of them is 6. This is what is going to be actual multiplication. Therefore, what we can write in general is, in general, let us denote sigma 1. Name of the summation is sigma 1, small sigma 1, which is alpha 1 plus alpha 2 plus alpha 3 plus dot 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 plus alpha n. Sum of all the roots, sigma 2, alpha 1 alpha 2 plus alpha 1 alpha 3 plus alpha 1 alpha n plus dot 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 plus alpha n minus 1 into alpha n. All possible ways of multiplying two roots at a time. What will be sigma? Alpha 1 alpha 2 alpha 3 plus alpha 1 alpha 2 alpha 4 plus dot 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 plus alpha 1 alpha 2 alpha n plus dot dot dot, what will be the last? Alpha n minus 2 alpha n minus 1 alpha n. Very good. This is how it is. And therefore x minus alpha 1 into x minus alpha 2 dot 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 into x minus alpha n is going to look like, now let us forget about that n, or let us write down a n is going to look like a n times x raised to n, that is first term, minus sigma 1 times x raised to n minus 1 plus sigma 2 times x raised to n minus 2 minus sigma 3 times x raised to n minus 3 plus minus dot 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 plus sigma r raise okay आता जरा थांबा plus minus 1 raised to something sigma r x raised to n minus r. Now, when this is even, this is plus. When this is odd, this is minus. When this is odd, this is minus 1 raised to r is my general term, plus dot 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 bracket. अरे समझते का? And this is going to be an x raised to n plus an minus 1 x raised to n minus 1 plus an minus 2 x raised to n minus 2 plus dot 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 plus a 2x raised to 2 plus a 1x raised to 1 plus a 0. Oh, now it is easy for us to correlate. Therefore, how much is an? An is equal to n. How much is an minus 1 equal to? N minus 1 will be equal to minus of an into sigma 1, which implies sigma 1 is equal to minus an minus 1 upon an. An minus 2 is going to be equal to plus of a n times sigma 2. This implies sigma 2 is equal to an minus 1 upon an minus 2 upon an dot dot dot. Therefore, a r Suppose AR is there in between somewhere. How will we write AR? AR is going to be equal to AN into minus 1 raised to R. बरोबर चाललंय?
minus 1 raised to n minus r.
Just a moment. Just a moment. N minus 1 AN. This is sigma 1 raised to. When it is n minus 1 here, it is 1 here. When it is n minus 2 here, it is 2 here. So I am going to write down sigma n minus r. But we want sigma r here. Therefore, let us make it sigma r here. This is what we are supposed to write. And then change the corresponding left hand side. So sigma r.